All right, in the last video, we started talking about transformation of graphs, and the only thing that we looked at was shifting, adding, subtracting, moving left, right, up, down. But the thing that we saw was our basic graph still had the exact same shape. And of course, we can do other things. And so the next thing that we're going to talk about is we're going to talk about stretching, and the book refers to it as shrinking. I grew up learning it as compressing. It's the same thing. But basically, we're going to talk about stretching and compressing. All right, so when we talked about shifting, we were talking about adding and subtracting. And so now we're going to bring in the next operations, which is going to be multiplying and dividing. And so, just like before, we have vertical and we have horizontal. When we talk about vertical stretching, just like with our shifting, stretching is going to be outside our function, and compressing is going to be outside our function when we are talking vertical. And so this is what we have. For a vertical stretch, if we are multiplying our function on the outside by a number larger than 1, then what this does is it stretches the graph vertically. So basically, we take all the points that are not on the x-axis, and we're going to multiply them by whatever our stretching factor is. So we multiply all y-coordinates by c. And again, if you multiply the y-coordinates on the x-axis by c, well, they stay exactly where they are because they are zeros. We also have vertical compression. And so the book does this a little bit differently than I do, but it's the same idea, is that if you have a fraction in front, then what we're going to do is we are going to compress or shrink the graph vertically by a factor of c or 1 over c. I like thinking in terms of c instead of fractions. And so what we do here is we divide all the y-coordinates by c. All right, these are going to be on the outside. On the outside is vertical. It affects the y values, just like previously. The other ones that we have is we have horizontal. And remember, horizontal, you do the opposite of what it says. So for instance, when we talked about vertical and we saw a 1 over c, we compressed or we shrunk it. Horizontal, we do the opposite. And so what this does is it stretches the graph horizontally. And instead of dividing, we want to multiply all of our x-coordinates by c. When we saw c on the outside, remember that we multiplied, but because we are inside, remember that we want to do the opposite. And so here I want to compress or shrink horizontally by a factor of c or 1 over c. And instead of multiplying by all my x-coordinates by c, I want to divide them by c. All right, so that's basically what we have here. Now, just like when we talk order of operations, there is a certain order that we have to do things. And so when we start bringing in, when we start combining these things, we do need to be careful. And so our order of transformations, under normal circumstances, we are going to do horizontal shifting. So we need to add or subtract our x values. Then we do our stretchings and our shrinkings or compressings. And we can do horizontal and vertical at the same time, because one of them is affecting x's, one of them is affecting y's. And then finally, we do our vertical shifting. And so just like previously, remember vertical, we do exactly what it says, and we do it in the order that we should be doing it. Vertical, when we talk order of operations, we multiply and divide, and then we add or subtract. With horizontals, we do it backwards. So we do the opposite of what it says, and we do it in the opposite order. So instead of multiplying and dividing and then adding and subtracting, we actually have to add or subtract and then multiply or divide. And I'll show you why when we get into some of the more complicated, and I'm going to say complicated examples. All right, so let's go ahead and start with just talking about our stretching, and then we'll add in the other stuff. All right, we are going to start with square root of x. And so we are going to go ahead and show what this does in terms of just the stretching and or compressing. All right, so for my square root of x, again, we want our parent function. And so my parent function is going to be, we're going to plug in 0, 1, and 4. And when we take the square root of these things, and you know what? Yeah, we'll leave it there. When we take the square root of these things, we get square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Okay, now, when we look at the 2 on the outside, remember this is 2 times the square root. And so this is going to be, because it is on the outside, it is going to be vertical. We are multiplying, which means that this is a stretch. And we want to multiply our y coordinates by 2. Notice that there is nothing inside my square root. We'll get to that later. And so what that means is my x values stay the same. And so we still have x is 0, 1, and 4. And if we do this the long way, if we do this doing computations, we plug in 0 for x. We get the square root of 0 is 0. We multiply it by 2, and we get 0. If we plug in 1, we get the square root of 1 is 1. We multiply it by 2, we get 2. If we plug in 4, we get the square root of 4 is 4. We multiply, square root of 4 is 2. Multiply it by 2, and we get 4. And so now when we compare our tables, what we have here is, notice my x's stay the same. And when we look at the y coordinates, what we've done is we've taken all of our y coordinates and we have multiplied by 2. All right, so now if we go ahead and graph these, if we graph our parent function, we have 0, 0, 1, 1, and 4, 2. When we graph our new function, we have 0, 0, 1, 2, and 4, 4. And so basically what we're doing is we're just pulling everything away from the x-axis. All right, let's look at one more example of the vertical stretching and compressing. Let's come down to example B. All right, we still have our same parent function. We're still going to plug in 0, 1, and 4, and we still get 0, 1, and 2. Okay, so now this time, what we're going to do is the opposite. Notice here, this is a 1/2. It's outside the function, and so what this means is it is going to be vertical. We are multiplying by something, and so it is going to be a stretch or compress. And here, this is going to be a compress. And again, the book uses the word shrink. And we are going to compress or shrink. And for me, I like to say 2, but the book usually says by 1/2. The only reason I say by 2 is because I'm indicating that I'm compressing or I'm multiplying by a fraction by using the word compressing. It's kind of like if you say what's the one that we've seen previously? If you're overdrawn by $100, overdrawn indicates that it is a negative. If you say that the slope is decreasing by 1/2, decreasing implies the negative. And so I kind of get into an argument with the book on this. Okay, so if you say compress by 2, I prefer that one. If you say compress by 1/2, I'll accept it. I'm not going to argue with you. Okay, now, so what does this mean? What this means is we want to divide the y's by 2. Okay, so if we go ahead and do this, again, nothing inside my function, and so my x's are going to stay the same. They're going to be 0, 1, and 4. All right, now my y's, I want to divide my y's by 2. And so if we take our first one, 0 divided by 2 is, well, 0. If we divide 1 by 2, we get 1/2. And if we divide 2 by 2, we get 1. All right, so now when we graph this, let's see what it looks like. My original function we said was 0, 0, 1, 1, and 4, 2. My new function, we're going to divide our y's by 2, and so we still get 0, 0, but now we have 1, 1/2, and we have 4, 1. And so notice that basically what we've done is we've brought our whole graph closer to the x-axis. And this is what a compression looks like vertically. All right, that is our vertical examples. The next thing we're going to look at is our horizontal examples. All right, so when we talk about horizontal, remember that this is going to be something on the inside. And so we are going to be affecting our x values. All right, let's go ahead and look at our first example. We're going to look at absolute value for these ones. And so in our first one, we have absolute value of x. And so I'm going to go ahead and create my table. Remember, for absolute value of x, we go -2, -1, 0, 1, 2. And we get that we're just going to drop our signs. All right, for our new one, just like we did with shifting when we talked about, okay, why do we do the opposite? Same thing here. What we have here is we know the absolute value of negative 2 equals 2. And I want to know, when is 1/2 x equal to negative 2? And so when we do this, in order to get rid of 1/2, we're multiplying by 2. And so we get x equals negative 4. And so when x is negative 4, we take half of it, we get the negative 2. We take the absolute value of negative 2, and we get positive 2. Same thing on all these other ones. We want to know, when is 1/2 of x equal to negative 1? And in order to do this, well, we need to multiply both sides by 2, and we get x is negative 2. So we get, when x is negative 2, half of negative 2 is negative 1, and the absolute value of negative 1 is 1.
Oh my gosh, you're able to see if I get it wrong. It's kind of embarrassing.
All right, from here, we follow the pattern. So if we multiply our x values, the remainder of our x values, by 2, we get 0 times 2 is 0. We get 1 times 2 is 2. And we get 2 times 2 is 4. All right, so now when we graph this, let's see what happens. Okay, so for my original function, we have absolute value. This is going to be our V shape. And it should look like this. All right, so now when we talk about the transformation, we do still have 0, 0. We have 2, 1, and we have 4, 2. And so basically, when we do this, is we are stretching this away from the y-axis. And so all of these points are being pulled horizontally. And our graph should look like this. Okay, now remember that we do want to be careful because, for instance, you could rewrite this as 1/2 absolute value of x. And even though the graph is the same, it is a different transformation. If we pull out the 1/2, now we are affecting y values, and we are shrinking them by 1/2. And so, for instance, all of these would be squished down towards the y-axis. And quite often, we're going to see that this is the case. It all depends on how do we want to approach it. The way that we are doing it, because we do want to talk about this in terms of being on the inside, is that we are talking about stretching it this way. All right, let's go ahead and look at another example of horizontal. And so just remember, sorry, I forgot to do this. Here, with the 1/2 on the inside, this is horizontal. We want to do the opposite. And so I want to multiply the x's by 2. And then we also call this a horizontal stretch. All right, let's go ahead and look at the next one. This will be our last basic stretch and compress. All right, so we start with our parent function. Again, we have absolute value. We take the absolute value of our numbers, we drop all of our signs, and so we get this. All right, now when we look at this, our 2 is on the inside. It is horizontal. I don't want to multiply by 2, because remember horizontal, we do the opposite. We want to divide by 2. And so this is going to be a horizontal compression or shrinking. And again, by 2 or 1/2. We are going to divide, because it is a compress, we are going to divide the x's by 2. All right, so when we create our table, notice we don't have anything outside our absolute value. And so my y values are going to stay the same. They are going to stay 2, 1, 0, 1, 2. My x's, this is what we're going to change, and we're going to divide all these by 2. So -2 divided by -2 is -1. We get -1/2. We get 0. We get 1/2. And we get 1. All right, when we look at our original graph, again, we have our V shape. I'm going to go with the nice points. I'm not going to work with the fractions. And so the ones that I'm going to go ahead and plot is I'm going to plot the -1, 2, the 0, 0, and the 1, 2. All right, when we do this, we have 0, 0. We have 1, 2. We have -1, 2. And basically what we've done is we have squished our graph in towards the y-axis. All right, that takes care of the basics in terms of stretching and compressing and what they look like. So the next examples we're going to look at, we have a graph. We're not told a function, but we can still apply these same techniques to just a picture. And so, for instance, if we look at the first one, we have a couple points here that we can work with. We're still going to do the same thing. So here, when we look at this, we have our 3 on the outside. Remember, this means that it is going to be vertical. We want to multiply by 3, so this is a vertical stretch. We are going to multiply our y's by 3. All right, so we can go ahead and do what we were doing before if you want to work with tables. And so if I look at my original function, f of x, we have some points here. We have -1, -2. We have 0, 1. You can also have 1, 0. That's this one right here. And we have 2, -1. All right, when we do our stretch, remember we want to multiply our y's by 3. And so our x's are all going to stay the same. We're going to have -1, 0, 1, and 2. And if we multiply our y values by 3, we get -6, 3. 0 times 3 is 0. And -1 times 3 is -3. If we go ahead and plot these now, We have -1, -6. We have 0, 3. We still have our 1, 0. And we have 2, -3. And I misplotted one. It did not quite look right. All right, we need to go up one more. All right, and then as best as we can, we are going to try to draw this. And this is what we get. Notice when we compare this to our original graph that, again, anything on the x-axis, because we are stretching vertically, all of the points that are on the x-axis pretty much stay where they are, and everything else gets pulled further away from the x-axis. All right, let's go ahead and do the next one. The next one, we have our 1/2 is on the inside. This means that this is going to be horizontal. We want to do the opposite of what it says. And right now it looks like we're making our x's smaller, which means I want to make them bigger. And so this is going to be a horizontal stretch. And we want to multiply the x's by 2. So we're going to start with the original table that we came up with on the last one. We're still going to use -1, 0, 1, and 2. We still have -2, 1, 0, -1. And now if we go ahead and multiply our x's by 2, we're going to get -1 times 2 is -2. 0 times 2 is 0. 1 times 2 is 2. And 2 times 2 is 4. We don't have anything on the outside, and so our y values will stay the same. All right, so now when we look at this, we have -2, -2. We have our 0, 1, 2, 0, and 4, -1. And this should be the graph that we come up with. And so here, notice that my y-intercept stays in the same place, and everything else is being stretched further away from my y-axis. All right, that takes care of these ones. The last thing that we're going to do is we are going to go ahead and come up with functions involving transformations. We are going to go ahead and talk about, we're going to combine our shifting and our stretching and our compressing. And so remember, we just kind of want to break this down into the different things that we've got going on here. Okay, so just like we did previously, we are going to start by figuring out what we've got. I start with my function. Again, we want to call it something different. So I'm going to call this g of x. We have our basic function, which is a cube root. And then we want to figure out whether what we're being given is a shift, stretch, compress. Is it horizontal? Is it vertical? Is it inside, outside? So the first thing that we have is we have shifted 3 units right. And so this is going to be a horizontal. This is horizontal, which means inside. And remember, we do the opposite. So if we're moving to the right, that's in the positive direction. This means I want to write it as -3. It goes inside my function, so we get the cube root of x minus 3 on the inside. The next thing that we have is we have stretched vertically by 2. Okay, so it is vertical. This is going to be outside. And because it does say stretch, remember this is going to be multiply by 2. And remember, we do exactly what it says when it's vertical. And so we're going to have 2 on my outside, and then we have the cube root of x minus 3. This is our final answer. All right, let's try a couple more. All right, for example G, we have f of x equals x squared, so I'm going to start with that. We have something squared. All right, the first thing that we are told is that this is going to be shrunk horizontally by 3. All right, so the first thing we have is it does say horizontal, which means inside. And remember that we want to do the opposite. When we say shrunk horizontally, I'm thinking divide by 3, but inside my function, that means I want the opposite of this, and so inside my function, I want multiply by 3. And so we are going to have inside our function 3x. The other thing that we have is we want it shifted 4 units up. And so this is going to be vertical. This is going to be outside. Because it does say shift, this means this is going to be a plus 4 outside my function. And we're done. All right, last one. We want to a square root function. We want to shift 4 units left. And so if we start with our function, we have g of x equals, we have square root. Because it says shifted 4 left, This is going to be horizontal. We do the opposite. If we're going to the left, we're subtracting 4, which means that inside my function, I want to rewrite this as x plus 4. We also have shrunk vertically by 3. This is going to be outside. And remember, we do what it says. So in order to shrink vertically, I want to divide by 3. But remember that when we talk about these functions, we want to think of it in terms of a fraction. So divide by 3 is the same thing as multiplying by 1/3. And so that's what we are going to put on the outside. It is going to be a multiplication. And so we get g of x equals 1/3 the square root of x plus 4. All right, that takes care of the majority of our transformations. We have one left. We will look at that one in the next video, and then we are going to combine all of these together.